Let's use de Moivre's theorem to find the 3 cube roots of 27. All right, so there it is. We want to write our answers in rectangular form. That's the one additional thing. First thing we need to do is write 27 as a complex number in polar form. And that will be of the form 27 times the quantity cosine of 0 radians plus I times the sine of 0 radians. Now, since we're looking for the cube root here, we know that n has to equal 3. And so from that, let's write the general form of de Moivre's theorem. It's going to look like the following. Z sub k is equal to the nth root, and again being 3, the cube root of 27, times the quantity. Give yourself some space here. It's going to be the cosine of 0 radians plus 2 pi k all over n, and as before we mentioned that n is equal to 3, and then we're going to have plus I times the sine of that same mess right there of 0 plus 2 pi k all over 3. So our formula is a little bit messy here, but we have I times the sine there, and we're going to be good to go here. Now, let's think about our k values. Remember, k starts at 0, and so let's sneak that in up here. We know k will be equal to 0, and then 1, but where do we stop? Remember that k stops at n minus 1, so we're going to be at 0, comma 1, comma 2. We have 3 values to plug in here. So let's start. We have z sub 0 is equal to the cube root of 27, which is simply 3. That's going to be equal to the cosine of 0 radians plus 2 pi times k is also 0 all over 3, again because k is 0, plus then I times the sine of that same value, 0 over 3, or simply 0. And from this we obtain the complex number, let me write it out, 3 times 1 plus 0i, and let me write that in here quickly, 0i, and so the cube root that we knew right off the bat, which was 3. Now we need to find the 2 complex in a similar fashion by plugging into our formula z sub 1. So we're going to have 3 times the cosine here. When k is equal to 1, we're going to be at 2 pi thirds plus I times the sine of 2 pi thirds. So that will give us the value of 3 times the quantity negative 1/2 plus I times the square root of 3 over 2. And so to distribute that through, we're going to end up with a negative 3/2 plus I times 3 square roots of 3 all over 2, and this will give us the second cube root of 27. Now let's find the third and final cube root of 27. All right, as before, we're looking at our value of k. For our final cube root, that occurs when k is equal to 2. So in general, we're looking for z sub 2, and it's going to be 3 times the cosine of 0 plus 2 pi times 2, which is 4 pi, all over 3, plus I times the sine of that same value. So here's what we're looking at. We have 3 times the cosine of 4 pi thirds, plus I times the sine of our 4 pi thirds. Using what we know about trig, we're going to come up with the following values. It'll be 3 times a negative 1/2 plus I, in this case. So let me get this out here. I'm going to sneak the I up on top. In this case, when we're looking at the second one, we have 3 square roots of 3 all over 2, but that has to be negative. So I'm going to write this with a negative out in front. So let's put this all together, clean up my poor penmanship here. We end up with a negative 3/2 minus 3 root 3 all over 2, and I'm going to put the I out on the rear there. So we've done it. We found the 3 cube roots of 27 using de Moivre's theorem.